Maybe make it a little bit bigger if I can get away with that, would be nice. Ooh, that's maybe too big. Right. So this was a question to do with death penalty. And actually all the information is given to you. It's here. So let's just show you where all the bits and pieces come from. So what proportion of the 2008 sample opposed the death penalty? And the answer to that is 0.327. Do you see where that one came from? And then the next question, for 1993, what proportion was it? It was this one here. And then it says, what is the estimate between the difference? Can you imagine you took this number, which is P1 hat, and subtracted this number, which is P2 hat? They're not calling them P1 and P2. In this case, they're calling them 2008 and 1993, but it's still 1 and 2, right? So if you took this decimal, and then you subtracted the other proportion, which is this decimal, can you see where that answer came from? 0.097. Now, write a 95% confidence interval. Now, normally we would do that as a calculation, but if you look really carefully, can you see it's here? 95% confidence interval for P1 hat, take away P2 hat. That's just the way that the software has written it. And can you see, I'll just copy the numbers here so you can compare them. Can you see the 0.67 to the 0.127? And then we're 95% confident that that's true. And this fella here is basically the formula that we're used. Do you recognize this ugly guy here with all the square roots? Is the standard error. Isn't that the difference between them? And that little guy they're calling Z star, in our case, wouldn't that be 2 for a 95%? And if it was a 99.7, wouldn't that be a 3? And if it was a 68, that would be a 1. So that Z is just a placeholder for it. And then if you plug the numbers in, they're using a slightly different version, which is 1.96, which is fine, but it's really 2 when you round off. Are we good? Right, now, let's give you a little bit of theory, and then we'll show you how pretty much everything that we've done can now be done by using SOLVE. Not only does it make it quicker, we can actually be more accurate. If I asked you to do a 95% confidence interval, you would do, I don't know, P1 hat, take away P2 hat, plus or minus 2 standard errors of P1 hat, take away P2 hat. And wouldn't you have to do a whole load of calculations just to come up with all these different numbers? And you would get your answer, and that's fine, it would be correct. SALT does a slightly different version. And you notice that there's a little difference in the number. When we do 1, 2, or 3 standard deviations, do you know that was a little bit rounded off, kind of easy to remember, 1, 2, 3. The 2 isn't quite 2. If you want to be exact, right, to get exactly a 95% confidence interval, you would use this number. Now, what does SALT do? Well, SALT does the entire calculation for you. So let's invent a story and show you how we can do, we can use it for SOLVE. Right. So let's have 2 populations, call them population 1 and population 2. And let's suppose we ask people, let's do the, I don't know, let's say 1 is Americans and 2 is Canada, right? And we ask them something and we want to see if there's any difference, right? So we ask them what percentage of them watch
hockey.
Hockey, yeah, hockey. And we found out from a sample, column N1, of 200 Americans, a random sample, that 20 of them said that they would watch hockey, right? They'd go to a hockey match like once a month or something, whatever you decide watching means. And then they asked 300 Canadians, and we found out that 80 of them, because I just want to make it 80, probably a lot more, right? Watch hockey. And we are interested in a 95% confidence interval for the difference between the two. Right. Now, if I turn these guys into decimals, because decimals are easier for my brain, and can I change that to 81 just because I want to make it a nice number? So 81 divided by 300. Yeah. Superficially, doesn't it look like more Canadians watch than Americans hockey, right? 10% Americans watch it regularly, 27% of Canadians. So we are going to find a confidence interval for Americans, take away Canadians, and it's going to be a 95% one. Now we have a whole batch of calculations. Remember that P1 hat times 1 minus P hat all over, and remember that takes 10 minutes, all that stuff. Don't need to do it. Salt's going to do everything. So I want you to just pretend you know these numbers. I've got them anyway. And I'll go in and we'll see if we can make salt do its magic. So I have no idea where I am. I think I hit that wrong blinking button again. No, actually I may have hit the right one. Here we go. Are we looking at question 9, for example? Right. So I'm going to hit the salt button. And I'll bring this guy over here. Can you now see salt? Yes? Right. Hit the distribution calculator. Sorry. Hit. Which one am I in? Yes. Hit inferential statistics. You see the top right-hand corner. Now go to this menu and pick 2 sample proportion. You see that one? Now, in the Americans, who's going to be number 1, there were 20 of them out of 200. So that's how you put in your information. You see, you don't even need to calculate the decimal, right? You just need to put in 20 out of 200 watch hockey. And the second group was the Canadians, and there was 81 of those, and there was a sample size of 300, right? So you're comfortable about how you put that numbers in, right? And then you go down here and forget about this. This is for later chapters. Hit the button that says confidence interval. And do you see right now it's got the number I want, because I want a 95% confidence interval. But can you imagine maybe the next time I want a 90% or a 99%, or just because I felt like a 99.992%, right? Whatever I wanted, couldn't I just type the number in there and it would do it for me, right? So I get a 95, we're good to go. Now, all I need to do is hit generate results and look at all the cool stuff that you get. There's P1 hat take away P2 hat. Can you see how the difference is, what, about negative 17%? Can you see the standard error? Remember that standard error with all the P1 hats and P2 hats and all that? There, it's all done for you. That's the lower limit, and that's the upper limit. So what does that mean? When you do your interval, the smaller number is negative 0. I'm just going to call it 235, and then the upper one is negative 0.105. And now we are done. We have calculated our 95% confidence interval. It was the lower limit, comma, the upper limit. Now, do you see it didn't give you the answer like that? You had to kind of read it off and know where to go. So far, so good. Now, that is correct. Being a percentage person, I see that as that. Now, you might and very often should get a question to finish this off. So you've found your 95% confidence interval for the difference between Americans and Canadians. And that difference is somewhere between -23 and -10. You agree all those numbers are negative. That's evidence to prove one of three things. Does that prove Americans watch it less than Canadians, more than Canadians, or you can't tell if there's a difference? That's the three answers you get from this. What does this one tell you?
Less than.
Right, tells us a less than. And in the context of the story, Americans watched hockey less than Canadians, right? Because one was American and two was Canadian. Suppose in a different world, a different question, the answer had been 10% and 12%. Would it not mean Americans watch golf more than Canadians, right? If all the answers are positive, does it not mean the first thing, we have evidence to prove that the first thing is bigger than the second, right? The first proportion is more than the second. And of course, this is the bad news one. You really don't want this one, but it does happen. Can you get an interval that contains 0? And when that happens, your answer is a bit vague. There's no evidence to prove that there's a difference. Right? We don't know if one's bigger or less than the other. It could go either way. We just don't have any evidence to say which. Do you like SALT as a less button pressing and more software doing? Right. So the question that they have that's in our homework, if I can now move my stuff out of the way, looks something like this. And I'm just going to write the question down. Here we go. A study was done to, no, this is question 9. A study was done to determine whether there is a relationship between snoring and heart disease. Interesting connection. In the first group, we're going to call them snorers. $82 out of 1,105 snorers. So they got a random sample of 1,105 snorers, and 82 of them had heart disease. And the second group was the non-snorers. And they got a sample of 1,379, and 26 of those had heart disease. And we are going to create a 95% confidence interval from this for the difference between them. So far, so good. So let's get some more practice at, what buttons you need to press to make all this happen. Right. So hopefully you're looking at question 9. I'm going to hit the SALT button. Bring this guy across. Okay. I'm in inferential statistics. Which one of these guys do you now pick?
Two-sample proportion.
Now, number 1 is going to be the snorers. So I'll tell you right now, because you probably don't have the numbers. It's 82 out of 1,105. And then I'll go to sample 2, which was the non-snorers, and 26 out of 1,379 of them had heart disease. And then remember to click confidence interval. And yep, it's already got 95. But just in case, can you imagine that maybe the next time they want a 99, you just type in that, or 90. If you want a 99, you type in that. You want a 95, you type in 95, and then just hit generate results. And the difference is about 5.5% positive. And the interval, or writing this down now, The 95% confidence interval is 0.0383 up to 0.0724 if you round it off to 3 decimal places. And, well, 4 decimal places, I should say. To 3 decimal places, can you see the 0.038 and where the 0.072 came from? Now, on the basis of this confidence interval, determine whether we can infer that the population with heart disease differs from the others. Well, they're not even telling you which way it differs, but would you agree that all of these numbers are positive? So does it not make snorers more likely to have heart disease than non-smokers? And that answer is yes then. And they just do it by what they phrase as does not cover 0. Now, if this was true data, does it not mean that, let me return back and we can see it as I talk about it. If this was true data collected fairly and was representative of snorers and non-snorers, that's what, about 3.8% to roughly 7.2%. Does it not mean that snorers have a slightly higher chance of heart issues than non-snorers? Now, it's not a big difference, you know, another 3 or 4%, but it might be important. So when your doctor's, you know, talking to you about symptoms, doctor might say to you, do you know if you snore? And you say, yes. Well, won't he put that down as one of his little check marks of not a good answer if I'm interested in heart disease? And if you have enough little check marks like, oh, you're overweight, that's a check mark for heart disease. You snore, that's a check mark for heart disease, right? Oh, you don't do a lot of exercise, that's a check mark. If you get enough check marks, won't you start thinking, maybe I should check your heart, you know, get an ECG just to, you know, just to be sure, right? On the other hand, if you don't have a lot of these check marks, you know, like you're a marathon runner and you're, you know, you don't snore and 40 other things that you don't do that are bad, he probably won't give you an ECG unless you come in and say, I'm getting these pains in my chest all the time, in which case that would be a baddie. Are we good with that? So as long as you know how to do the information, we should be able to calculate this thing, right? I think that's about it. Let's look at number 10. Last one, and we'll move on to the next section. Oh, now I'm changing the question. They keep asking for a 95% confidence interval. Can we pretend they've got imagination and they ask for a 99 occasionally, just because I want to try another number? So in this version of question 10, so I'm changing the question a little bit. 95%, and so this is group 1, this is women, self-identified women. 95% of a sample of 300 said they would marry their spouse again. Well, actually, I misread that. That's the men. That's the women. Which is it? It is the men. Okay. 95% of men said they would marry the same woman again. And they went and asked some women the same question. And there was 500 women, married women, I'm assuming, and they asked them, self-identified women, would they marry their partner again? Would you agree that that is different? Don't know how accurate it is, but it is different. And we have to take this information and we are going to create a 99% confidence interval using SOLVE. There is a problem with this. The information that they've given me actually isn't the numbers that I need. don't I need the something out of version? So I'm going to have to do a little calculation myself. I'm going to have to find out what 95% of 300 is. In other words, I'm going to find the raw data. How about 0.95 times 300? And that ends up being 285. Are you happy with how I got 95%? Right, what about the 85% of the women? 85 times 500, and that ends up being 425 out of 500. Before we do the final analysis, which is creating that interval, do you think that there's a big enough difference here for that to be statistically significant? In other words, do you think this interval's always going to be positive numbers? Do you think the difference between them is big enough? What's your gut feeling? No. I don't know, is my answer. If I had to bet money, I think there is, but that doesn't mean I'm right. I could be wrong. So let's find out what the answer is, because a 99% interval is pretty big interval. So here we go. So two sample proportion already set up. 285 out of 300. This is the men. Scroll down to the women. It's going to be 425 out of 500. Turn that number into 99% and generate the results. And the limit is 0.047 to 0.152. And that was it. Let's see what that looks like. So what, about 4%, anywhere as high as 15.2%. So yep, there is evidence that men would marry the same person again more than women. Are we feeling comfortable about using SALT now? In fact, if you had to do it by hand, which you do in the early questions, and then you went and did it with SALT, could you use SALT as a way to check? Right. So we are finished that section. And I'll move this fella somewhere out of the way. Close this off. And let's go and see what's in store for us next. But our next section is chapter 2, which is really similar to what we've already done. Just try to hit the right button. There we go, that's better. And the way this, I guess the way they like to do things is that they keep returning to things that we have done before, right? So you're going to be looking at samples and proportion questions. Is this a sample? Is this a population? Is this a parameter? Is this a statistic? You know, things like that. And then I guess it's good to revise. And then later on in that section, you get to use SALT with very similar looking questions. So here it goes. Are you all looking at chapter 10, estimating the value of a single proportion? Right. So let's start. In each part of this question, explain whether the proportion that is described is a sample or a population. Okay, remember, is this a sample? Is this a population number, right? In 2010 United States Census, it was found that about 1 in 8 Americans were at least 65 or older. Is that piece of information a sample proportion?
It's a population.
You agree? There's one word in that entire description that kind of led me to the population proportion. What was the word that you think made me decide?
Census.
Isn't a census? You ask everybody. So, yeah, nice easy question. Let's do C. In a clinical trial done to assess the effectiveness of a new medication for asthma, a satisfactory relief from symptoms was experienced by 59% of the 70 participants. Sample or population proportion?
Sample.
I
Sample.
can't argue with that one, Rob. Sometimes it's so obvious, it's hard for me to say why I know it's a sample. Would you agree it's kind of obvious it's a sample, just the whole way it was set up? I mean, for that to be...
How is it a sample?
Yeah, I think they did even say the word sample somewhere. Oh, good, at least they didn't do that. But I mean, for that to be a population, wouldn't you have to find every asthma sufferer in, I guess, the world, or at least America? No evidence that they would do that. Here's a different, again, this is review, nothing wrong with review. A survey is done to estimate the proportion of American adults who think that texting while walking across an intersection should be an illegal thing. In a survey, 56% of the 1,055 individuals said it should be illegal. Okay, so in that story, what is the population? There's 1, 2, 3, there's 5 dots.
All US adults who own a cell phone?
No. I like all US adults. To me, the clue is right there.
Oh. So it's just all US adults.
Yes. Would you agree?
Okay, yeah.
Right. Okay. What is the population parameter of interest? Right, there are 5 dots there. What is the population parameter? In this case, it's a proportion. Which one of those 5 are you trying to find? Which dot is it? 1, 2, 3, 4, or 5?
Would
I'm
it be
gonna go
3?
with 2.
All right, I have a 3 and a 2. I agree it's one of those 2. Now, the reason I'm picking 3 is the same kind of reason we threw out a version of 2 the last time. Isn't the proportion of all US adults that we're interested in, not the proportion of everyone in the US? Because we don't want to ask 4-year-olds, right? And we don't want to ask 14-year-olds either, right? And was it the information based on US adults, right? Right at the top, although you can't see it now, right? Right at the top. There, right, you see it? So you have to be like a lawyer, right? You have to be quite nitpicky about every word as a prisoner, right? Every word is important. You can't let they get away. And which one of these then is the sample? 5 dots. Which number is the sample?
4.
Agreed. And the sample statistic, well, I'd have to go up here and find out, is 56%. Now, do they want it as a statistic? Well, if they want it as a percentage, I guess I have to do that. If they want it as a decimal, I guess I would have to do that. But since you get 5 shots, you can figure it out yourself. Are we good with that? Now, we've talked about this in other days. What is the likelihood that a 99% confidence interval will not actually get you the right answer? That's me paraphrasing this. Now, don't overthink it. In a 99% confidence interval, what percentage won't work? What percentage of time will you actually not get the right interval?
1%?
As simple as that. Right, in a 95% confidence interval, won't you be wrong 5% of the time? What I mean by that is that the interval that you get doesn't contain the real number, right, the one you're after. In a 90% of the confidence interval, won't you be wrong 10% of the time? In other words, your interval will not contain the true value about 10% of the time. That's quite bad, isn't it? I mean, if you crossed the road and there was a 10% chance that you did it wrongly, you'd eventually get hit by a car, wouldn't you? You wouldn't risk your life on that kind of interval. But do you know there's a lot of data out there that is evidence, and it's using 90% confidence intervals? Doesn't that mean 1 in 10 of the things that you're told that use that is actually wrong? Now, I don't mind if they tell me that people like Pepsi more than Coca-Cola. I don't mind if they get those things wrong, right? 1 out of 10 times, right? I don't mind if they get what's the most favorite movie, and they get that thing wrong 10% of the time. But if they tell me what level of drug I should be using to help me with my heart, I don't want to get that wrong 10% of the time, do you? I mean, that would be a lot of dead people, right? So can you imagine that the percentage of a confidence interval needs to be based on how serious an error is? In other words, if I get it wrong, how bad would the result be, right? If you do an election, does it really matter if you get it wrong? Because the election's going to happen and whoever it is wins, right? So it's not like the end of the world, right? But if you are basing your results and sending someone up to space, do you really want to be 90% sure you got it right? I don't want to be in a spaceship if I'm 99% chance of being right. I want to be 99.99% chance that, whatever they tell me is right. So confidence intervals are important because they put a level or a degree of confidence on what we want. And to finish that, a 99% confidence interval means that the interval will cover the true value 99% of the time, right? Don't a 90% confidence interval mean that we get 90% of the time the true values in there? That's their phrasing. Well, let's look at 4. A certain poll surveyed a random sample of 438 teenagers. One question that was asked was, how strict are your parents compared to most of your friends? Very subjective. The choices were my parents, right? My parents are more strict than my friends, less strict than my friends, or about the same strictness as my friends. I'm going to stop for a minute and think to myself, do you know if you ask most teenagers, aren't they all going to say that their parents are more strict than everybody else's? Okay, maybe not. I would think that's what I would get, because it's a very subjective thing, isn't it? How strict anybody is. But anyway, I'm just criticizing the way they did it. Right. The choice was more strict, was 166 of them. Suppose, in fact, the true population percentage who think that parents is more strict is 40%. Okay. So they asked 438 kids, and 166 said that's what it was. I'm doing a quick check on that. 166 out of 438. Out of this one sample, it was about 38%. The real answer is 40, right? Somehow we know the real answer is 40. So that was pretty close, 38. Now here's the question. Suppose you asked another 438 students from the same population, of course. Which of the following would be true? The number selecting the choice more strict would again be the same number as it was here. The number selecting choice would be more strict would never be that number, or the number selecting choice more strict would be again that number. So it either couldn't be it, would be it, or could not be it. I'm thinking that two of them is the same. Let me read it again. The number selecting the choice more strict could be, there it is. There's every word is a prisoner here. Which one of these three dots is actually the correct response? If you asked a different 438 students about your parents being strict, which one of those three choices, 1, 2, or 3, would you reasonably assume to harm?
One.
I agree. Why are you picking 1? It's the right answer.
Because I guess it gives room for growth.
Okay, it gives room for differences. That's as good a reason as any. The reason I'm kicking out the other 2 is why 1 is left. So I'm just throwing the other 2 out as not likely. When you do a sample of 438, isn't there a variation in the answers? Isn't each time it going to be a little bit different than the next? Right. So it could not be 166 again. Isn't there a small chance that it might actually be exactly 166 again? Right. Good harm. Or it could not be, right? Well, that's kind of just the same thing in reverse, right? Every time you do a sample, anything could happen. And the same number again could happen. It could be different. It could be more. It could be less. So I'm kicking out 2 and keeping that. Now, if a new sample of 438 was from the same pop, which of these would be true? The true population percentage couldn't be 40, would be 40, could be 40. So it could not be 40, could be 40, or it would be 40. God, that's just very similar sounding. But one of those is right. The population percentage, is it would be 40 again, would not be 40, or it could be 40? Which of those is it? And I'm picking the second one this time. The population number doesn't change in the context of the story. Now, maybe 10 years from now it'll change, but right now it's the same number all the time. What does change is your sample, right? You ask a sample, you get one number. You ask a different sample, you get a slightly different number. But aren't all those samples variable? But the population is not considered variable. The population is fixed at that snapshot in time, at least. So if it's 40%, it'll be 40% 10 minutes from now as well. These are very similar questions, so I won't do that one. Here's a different question. A question given on MSN.com in 2020 asked, how good are you at maths? And as of that date, based on over 300,000 people who responded, 18% said they were very good at math. Can the method of this chapter, can this method be used to compute a 99% confidence interval? I am not going to use that data to make any confidence intervals or any other prediction of any kind. What is wrong with that sample? Don't even need to look at the list. We'll look at the list in a minute. What's wrong with having a questionnaire in MSN.com? It's a very special problem. Aren't these people self-selected? Didn't they go to MSN.com and didn't they choose to take part? Will that give you a fair representation of everybody in America now? No. Don't you only get people who go to MSN.com? And then within that subgroup, don't you only get those people who are bothered to answer the questionnaire in the first place, right? So you are breaking the first rule of all data collection. Isn't it that your sample should be a fair representation of your population? And if your sample is biased, in this case it's biased because of self-selected, you should never do anything with the data, right? What's that the equivalent to do? Suppose I wanted to know what percentage of American adults thought they were good singers, right? And I decided that the way I was going to find that data was only go to karaoke clubs and ask people there, are you any good at singing? Can you imagine that the sample I got would be biased? I'm assuming that people who go to karaoke clubs, most of them sing and therefore think they are good singers, or are more likely to think they're good singers. See how the data is biased. How else could I do it? Let's figure out other ways of bias. Can you make bias by the way you ask the question, right? Can you have bias by who you ask? Can you have bias in the sampling techniques that you use? Like only ask men when you want to know everybody, right? Remember that whole list of different ways of getting it wrong? That's just one of them. And I'm going to nip out for a second and show you a term that I have mentioned, but I'm not sure I mentioned it enough times. Imagine that we were doing a 99% confidence interval and we got to 0.51 plus or minus 0.03. You know that towards the end of the calculation, doesn't it look very like that? We give a number to this guy. He's called the margin of error. I believe right now that, I think Virginia's been declared. Is New Jersey still too close to call right now, or is it being declared? Does anybody even know? There's some elections going on, don't matter. Right, it's called the margin of error. We would normally call this 51%, give or take 3%. So we would say the margin of error is 3%, right? Okay, now we know what margin of error is. Here is the story from question 7. A survey was conducted and 48% of the people selected said they did not get enough sleep, and it was a 95% confidence interval, and 48% said they did not get enough sleep, and the margin of error was 3.3%. So that's essentially the information that we need to know. A 95% confidence interval, 48% said they did not get enough sleep, and the margin of error was 3.3%. If I give you that information, shouldn't you be able to create the confidence interval? Right, 48, add and take away that. If you take that away, you get 44.7%, and if you add it, you get 51.3%. Are we good with how that was done? Now, what we can then do is a whole sentence. I'm just going to read it out to you. With a 95% confidence, we can say that the population of American adults is between 44.7 and 51.3%. Right, so they basically got a sentence where you use this information and you fill in boxes. Actually, I should be able to return and show you that. Maybe it's easier if you can see it. Okay. So in this question, it was 44.7. And then it went to 51.3%. And with a 95% confidence, all American adults between 44.7 and 51.3. Now, here's the last piece of this. Do you think that this sample could be used to estimate the percentage of college students who do not get enough sleep? Now, this sample was only randomly selected adults. But could you use this interval and say it's probably true for college students? What's your gut feeling about that? Right. Robert, you're shaking your head. Give me a good reason. Why do you think it's not the same?
Well, college students could be your age range from depending on when they started college, so they're not adults, because there are college students that are younger than 18.
Okay.
The type of well, that's the main one. So it doesn't describe the sample that we want enough.
Right. So you think that college students are probably different from the population? Some,
Yes.
For one pretty reasonable assumption is that there are a lot younger ones in it, right?
Yes.
I would totally agree. Would you agree that college students probably have a different lifestyle than the general adult population?
That too.
They may party too much, in which case they don't get enough sleep, or they study really hard and therefore still don't get enough sleep. So my guesstimate is that it's probably going to be higher if I had to guess at all, right? So you've got some choices there. You pick which one you like. Question 8 is pretty much the same type of question. Scanning through the question 9 here. That's pretty straightforward. Okay, question 10. Taking into account the purpose of a confidence interval, explain what is wrong with the following statement. Based on the survey data, a 95% confidence interval estimate of the sample population is 0.0991 to 0.115. Which one of those 5 guys? I don't know if you can read them all. Maybe I could make it a little bit bigger. Can't do that. Can't read the end. Anybody got an answer? Because I don't. I want to see if you can tell me which one of those 5 dots you're going for. And it might be because I haven't read section 10.1 of their book, so I don't know what the reference is. I'm going to cheat. Unless somebody wants to tell me right now what one of those dots, I'm going to cheat and find out which dot it is, and then I'll try and explain why I think it's that one. But right now, I'm not sure, because all of those look wrong to me in one way or another, or at least 2 of them are equally right. But either way, I can't commit to one. Okay, so it's question 10. Let's put in those two guys, see what we get. A confidence interval is an interval that estimates a population parameter, not a sample statistic. Well, that is true, but there is nowhere in that sentence, at least there's nowhere I can see, where they mention that that's what you were estimating. Can someone see why they picked that one? I know it is true.
The only thing I can think of is they use the word sample. It does say estimated the sample proportion. And that's the only clue I could see.
God, yes, every word's a prisoner. You see the word sample there? Right? Should not be a sample, should not be population proportion. Yeah, that's it. But I mean, that was like being a lawyer. Didn't you have to read each word and check it? And I scanned by it 3 times, never even saw it. Okay, thank you. That was good. I'm happy that that answer now makes sense. Okay, let's get these other answers out of the way. They are out of the way, so I can associate them. Okay, we're almost coming. And time has got the better of us. So last name.